Okay, so we're just going to go over some review questions for the final. I'll just have you guys help me out and solve them. So if we look at that first one, what is it asking us to do? What would I use to factor? Which magic numbers? What would those magic numbers be? Yep. So then I have s minus 10 and s minus 4. Okay. So in this case, our a is 1, so we don't need to split in groups. So we don't need to do s squared minus 10s minus 4s plus 40. We can just jump to this stage. I'm feeling okay? Alrighty. And if there's any of these that you want to do on the boards, just let me know, okay? Because I wouldn't want to sit there the whole time either. What about this one? What can we do? Kind of gives you a little hint over there, right? So when we use split and group, what do we have to do? What's our first step usually? A times c. So if I multiply a times c here, what do I get? 24. So what multiplies to 24 adds to 11? 8 and 3. So then I have 6x squared plus 8x plus 3x plus 4. Okay, what's my next step? Take out a 2x from the first two. So then I have 3x plus 4. And what about over there? Okay, we can take out a 1, but that's just going to leave us the same thing. Okay, so then what are my two factors? Those are my zeros. We want the factors. Yeah, 3x plus 4, and then 2x plus 1. Any questions with this one? This is a lot nicer than what you've been doing, huh? Yeah. What about this one? Yeah, difference of squares. So we got b plus 5 and b minus 5. Okay. Now what is it asking us to do? Because we have the factors. We want to yeah, we're finding the zeros, so we're solving it. Yeah. Which property tells us that we can set them both equal to 0? Do you remember? Yeah, just the zero product property. So then, if I solve this first one, 6x minus 5, how do I solve it? Add 5 divided by 6, yeah. So then I get x equals 5/6. Okay, what about the other one? Yeah, subtract 7 and divide by 3. So we're at -7/3. Feeling good? Okay. Do you want to do this one on the boards? Sure. Okay, what's the easiest way to solve this equation? Magic numbers, yeah. You can use the quadratic formula because that always works, but magic numbers are a little easier. So what would those magic numbers be? Yeah, x minus 9 and x plus 2. And then if I set those equal to 0 and use the zero product property, what would be my solutions? 9 and negative 2. Okay, how would I solve this one? We could use difference of squares. So like you'd factor this and then set them both equal to 0. Yep, we could do that. What's another way? Yeah, since we can point to a single x, we can isolate it. So then if we add 9, we get x squared equals 9. So then x equals what? Yeah, plus or minus 3, which is what you would have gotten using difference of squares as well. Seems too easy now, doesn't it?
Yeah.
Okay, what about this one? I could divide it by 2. Do you want to do that? We can't divide by our variable, because then we'd lose a solution, but we could factor it out. So if we factor out a 2x, we have what on the inside? X plus 8 equals 0. So then what are my two solutions? 0 and negative 8. Okay, what about this one? Yep, so 100 divided by 4 is 25. So then the square root of 25 is plus or minus 5, yeah. Remember the plus or minus. Okay. So we're going to go over just like the steps for completing the square with just the generic equation ax squared plus bx plus c. Do you remember the first step? Move over c, yep. So move over c by like rewriting it. What do we do after that? Half of b squared, yep. Oh, I guess, yeah. We were kind of assuming a was 1, so then it just says divide both sides by a if a is not 1.
When you move over c, will it become negative c?
Yes, it would, but since c is just some number, we can say, oh, it is negative over here. But yeah, you would be right. Like if we had a positive 3 as c, then it would be minus 3 right there. We doing okay? Okay. So if we divide by a, then we can add the b over 2 squared to both sides. What do I do after I add that? Where's the Jeopardy music? Why did we use that? Why did we find that b over 2 squared? Yeah, we can factor this into just a perfect trinomial. So then we get x plus b over 2, quantity squared. And then after I have all this equal to some number, what do I do? If I set it equal to 0, I'd solve this over, or move that over. Yeah, we can just use inverse operation since I can point to a single x. So I can just solve by isolating it. We doing okay with just like the basic steps? We'll get into some. Actually, I don't know if there's an example or not. Let's see. Oh, kind of. Okay, so if we look at this one, we want to use completing the square. So we have x squared plus 30x. What's going to be my c? 15 squared. Because we have b over 2, which would be 15 squared. So what is 15 squared? 225. Okay. So then when it's factored, what does it look like? X plus 15 squared. We feeling okay with these, or do we want another practice problem? Up to you. You'll probably get one on the review assignments too that he posts. Okay, what about the quadratic? What's our first step when we use the quadratic? Not the formula yet. Put it in standard form, yeah, we have to set it equal to 0. Okay. After I set it equal to 0, what can I do? Or there's a little something else we want to look for to make sure it's kind of nice to plug in. We didn't do a whole lot of work with it. We want a to be what? Preferably 1, yes, but what else? Yeah, we want it to be positive, right? Because then there's less negatives that we have to do, because we'd then be dividing by a negative if a is negative. Okay, how we feel about that? It's an additional step that can be helpful, but it's not needed. Okay? So after it is in that form, what do I do? Yep, plug it in. And what's the equation again? Yeah. Do we want to listen to it again? No? You just got it out of your heads?
Just
So.
let Caleb sing it.
I think you should sing it
I
instead.
agree.
That was good.
I haven't memorized, but every time I write it down, as soon as
Mm-hmm. Yep.
Listen to your harmonic voice.
I don't do it. I only do it to the square root part,
And then you stop. Yep. I remember listening to it when I had Oya, and like it's been ingrained in my brain. Okay. Let's see. Yeah, let's do this one and then we can call it a day. So what's our first step? Multiply by -1 to get a positive a value. So if I multiply by -1, what's my equation going to look like? Yep, 8x squared minus 6x minus 9 equals 0. Okay, so what's my, if I plug it in to the equation, what's it going to look like?
6 plus or minus square root of 36.
Times -9. 16, okay. Does anyone have a calculator? If not, I know I was working it out. It becomes a perfect square of 18. Do you take my word for it, or do we want to work it out?
I think we should work it out.
We should work it out? Okay. Let's have you multiply all these.
Yeah.
I think it simplifies to 324 or something like that. Because if we do 32 times 9, so 8.
72 times 4.
Yeah. So we got 36 plus 288 all over 16. And then 36 plus 288 is 324. Okay? And then the square root of 324 is 18. Okay? So then we get 6 plus or minus 18 over 16. Okay, what would I do next? Yeah, so we could do 6 plus 18, which is 24, over 16, which reduces to 3 over 2. Okay, and then we have to do 6 minus 18, 12, negative 12 over 16, which reduces to negative 3/4. So then these would be the solutions. Feeling good so far? Okay. I won't start anymore because I don't know how long it'll take us to solve this one. So we'll end there. So we worked on this one, right? Our first step was making a positive and then plugging it in. Do you guys want to get up and do one, or do you want to sit for a little longer? Okay. Go for it. Oh, yeah. Okay. Do we want to go through this one? Are we feeling good? So we'll skip to like this step. Over 2. So then what did your square root simplify to?
4 squared root of 5.
Yeah, 4 square root of 5. Over 2. So what was our last step then? Yeah, these are both even, so we can divide them by 2. So we get 4 plus or minus 2 root 5. And how many solutions do I have? 2. Was it picky with putting it in as 4 plus 2 square root of 5? Do you remember? Was it like picky if it was like 4 plus 2 square root of 5, or could you use the plus or minus? You can.
I heard that it didn't work for some people, but
I've heard both.
Yeah, I think it depends on the.
If it was in the bottom bar, it would.
If it can be simplified further easily, then I think you can't do that. Otherwise, no.
So like you could do it at this stage, but if we couldn't do it here.
No, I don't know. That would be wrong. But the 4 plus or minus.
No, you can. But if you had like 4 plus or minus, and it's just a 2 and not square.
Oh, it would want the number.
Yeah.
Okay, I got you. Okay, how are we feeling? Good? Okay, we're gonna go back to what we were just doing, that unit. What were the steps when we just simplified rational expressions? Factor? Yeah, factor. And then after we factor, what do we do? Yeah. Cancel common factors. So if we look at this example, how do we solve it? Or simplify it? What would I get if I factored the bottom? Yep, x minus 5, x minus 2. I want blue. X minus 5. Then you have x minus 5 and x minus 2. It doesn't ask us to do this, but what would be my excluded values? 5 and 2, yeah. And then what would be the simplified answer? 1 over x minus 2. Okay. Not too bad, right? Just the simplifying portion. Okay, what about when we multiply rational expressions? What's our first step usually? Factor again. And what would we do after we factor, you think? Yeah, cancel. He puts extend the division bar. So just connecting the two fractions and then finding those exclusions. So after we do that, we just cancel like factors. Okay, so if we do this one, what's our first step? Factor the top. What would those magic numbers be? Can you see it okay? I think I figured out how to zoom in if we need to do it. We can see it, okay. So what would my factors be? Yep, so we got that first one staying the same. And then we said that it factors into x plus 6, or no, x plus 9, x minus 6. And then do we do anything with the denominator? No. Okay. What would you do next? Cancel? Yeah. What would cancel? We have this one? Just those two, right?
If Jay could actually tell him to come over.
Okay.
Yeah, got it.
So then we have x minus 5, x minus 6 over x plus 5. And then there's one more thing we have to do. Yes, x cannot equal -9 and -5. You doing okay with multiplication? Could I have put those into one fraction and then canceled? Yeah, you could have. It's not necessary. Okay. What about adding or subtracting? What's our first step? Factor what? Yeah, we just could factor the denominators in this case because we have done examples where we factor both the top and the bottom and then we end up having to unfactor the top, right? So we can factor the denominators only and find the LCD. Then what would we do next? Multiply the LCD. Well, not the LCD, but like the missing factors to get that LCD in the bottoms, the common denominator. Then after that, what do we do? We've got to do something before we can simplify. If we add and subtract. They have the same base, so what do we do? So you're thinking like what the example one that he did, right? That's when there's an equation. In this case, there's nothing we're solving for. We're just adding them. Yeah, we just add and subtract the numerators and put them over that common denominator. And then we can simplify. I'm going to have you try this one. So I'm going to cover it up while you go to the boards. Okay, do we feel the need to go over this one? No, right? Okay. Okay, what about when we simplify complex fractions? What's our first step? Yeah, we'll factor. That's not what it has up here, but that's a good point. We're not trying to get rid of it. We're trying to just have a single one, right? So we want just one fraction in the top and one fraction in the bottom. And then after that, we can multiply by the reciprocal. Then we can simplify. And what's important for when we find those excluded values when we're doing this type of stuff? What's important to look for?
Exclusion.
Yeah, the exclusions. There's something that's a little bit different when we do the multiplying by the reciprocal. Yeah, we have to check before we flip it and also after we flip it. So that's what this box says, just that any zero at any stage that's in the denominator has to be excluded. Okay. So if we look at this one, we can kind of break it up into pieces so we can simplify that top first. What would I have to do to put them together? Okay, so what would that become? 9x over x. Oh, that's huge. Oh, no. Okay, so you got 9x over x. Is that too thin? No. Okay. Minus 9 over x. Okay, and then if we look at the bottom, what would we have to do? Yeah, so we want this x to have a 6 in the denominator. Then we get 6x over 6 plus 7 over 6. Okay. What would I do next? Yeah, so what would this be if I put it together? 9x minus 9 over x. Okay, and then what about the bottom? 6x plus 7 over 6. So do I have a single fraction top and bottom? What can I do? Multiply by the reciprocal, yep. So we keep the top, change to multiplication, and then flip the bottom. Are we going to get any cancellations there? Nope. So in this case, we could just write those different factors. X and then 6x plus 7. And then there's one thing I have to do. What would those exclusions be? Yes, we got x cannot equal 0 and negative 7 over 6. You feeling okay with these ones? I know these can be a lot. Okay. Okay, so we're now looking at solving the equations. So what were the two ways that we could solve equations? That's one of them, yeah. Cross multiply, and then what was he doing? Yeah, multiply by the LCD to cancel out fractions. So we've got to factor out the denominator, find that LCD, clear fractions by distributing, and then solving. In this case, they didn't have the cross multiply. So what would my LCD be here? X squared. So I can just multiply everything by x squared. So if I do 1 times x squared, we get x squared. And then if I do 11 over x times x squared, 11x. And then equals what? Yes, negative 18. Those x squareds just cancel. Does that have an x? Yeah. Okay. 11x equals negative 18. Okay, how would I solve that? Yeah, move the 18 over, get it in standard form. Plus 18 equals 0. Then what would those magic numbers be? Negative 9 and negative 2. x minus 9, x minus 2 equals 0. So what are my solutions? 9 and 2. X equals 9, 2. And then would I have any excluded values? Yep, 0, right? Because I have these in the denominator. Does that make any of my solutions invalid? No. Because we just have 9 and 2. Okay. Doing okay? Do you want to do this one on the boards? Sure. Okay, what'd you do to solve this one? What'd you do to solve it? Okay, because that's our LCD, right? If we multiply by 5x, because if we have, look at this, that factor's already in our LCD, so we don't need to do it twice. What would happen if we multiply negative 6 over x by 5x? Negative 30. Those x's would cancel, and then it'd be negative 6 times 5. Okay, and then what about negative 4 over 5x times 5x? Negative 4, and then 3 times 5x plus 15x. Did I say negative 3? Okay. How do we solve for x? Add 4, so then I can get negative 26 plus 15x. So what's my x value? Negative 26 over 15. And in this case, we cannot reduce it down, because the only factors of 26 are 2 and 13, and neither of those go into 15. So this would be the answer. And then, I don't know if it asks, but what would the excluded value be? Yeah, 0. We doing okay with solving them? Okay, so this is the other way. With proportions, what do we do? Or what is a proportion, first off? Let's see that. Sorry, I asked like 3 different questions right there. What's a proportion? Yeah. We have a fraction equal to a fraction. And then if we have a fraction equal to a fraction, we can just cross multiply. Yep. And then solve from there. So what would I be multiplying here? Yes, we have 4 times x minus 9 equals 2 times x minus 4. Okay, I don't know if you struggle with it as much, but I have seen people do like 4 times x minus 9 over 2 times x minus 4. Do we feel okay about why they're equal to each other and not a fraction?
Not why, but I know it is. So it's just
Well, like if we wanted to get rid of this denominator, we just multiply both sides by it, right? So then we'd get 2 times x minus 4. And then we'd have to get rid of this denominator, so we'd multiply both sides. Does that make
so it's just
Yeah. Okay. So if I distribute those out, what am I going to get on the left side? 4x minus 36. And what about the right? 2x minus 8. How would I solve for x? Move the x's to the left, so I'd get 2x equals 28. Add 36 to both sides. So then x equals 14. And if we kind of just look, is that solution valid? Yeah. Okay. We good with proportions? I think we have time for this one. Do we want it to do it together? let's just do it together. Why not? So what would my first step be? Factor the bottom. So I could drop this fraction, drop this fraction. What would my factored denominator be? So we got x plus 3 and x minus 1. Okay. What do I do after that? Yep, we multiply by the LCD, which in this case, yes, x plus 3, x minus 1. So what would I get for this fraction? X plus 1 times x plus 3. Okay, and what about the one with the negative 9? Negative 9 times x minus 1. And then what about at the end? Just 8. Okay. What would I do next? FOIL, so I'd get x squared plus 4x plus 3. We okay? Okay. And then negative 9x plus 9 plus 8. So 17. Could I put it in standard form? So then I'd get x squared. If I move the negative 9 over, I get what? 13x. And then if I move the positive 17 over, sorry, yeah, positive 17. Negative 14 equals 0. What would I use to factor that? What's the easiest way? Magic numbers, yep. What would those magic numbers be? We want x plus 14 and x minus 1 equals 0. You're going for the zeros? What would those solutions be? Negative 14, positive 1. Okay, we didn't find them before, but what would my excluded values be? So x can't equal negative 3 and 1. So what would that mean for my solution? Yeah. 1 does not work. So it'd just be negative 14. You doing okay? Let's see how long the next one is. Yeah, we'll start there tomorrow. We're almost done. See that we're here a little bit earlier. There's only 7 questions left that we have to do, so we'll get through those pretty quickly, and then you can have the rest of the time to just work on math, chemistry, whatever really. So what do you remember about simplifying radicals? When there's like a number and variables on the inside. Okay, so like the power of the radical determines how many you need before it can come out. Okay, I like it. How could we write those exponents? Yeah, you can turn them into fractions and then mixed numbers. Let's see what's under this box. So you just break it up, yeah. What would the x, can you see those exponents very well? Okay. So we took out 288. What about x? What would that break into? You don't have to. Okay. We'll just write them as fractions and then we'll do that. So what would the fraction for y be? About 1/4. Okay. And then what about z? 18 over 4. Yep. So then once we kind of split it off, we can just simplify it. I won't make you factor 288. I'll just show you. I trust your guys' abilities to do it. So we notice that there's more than 4 2's. So we can group that bunch and pull it out. So what would be left on the inside? 18, yeah. Because you just multiply 2 times 3 and then times 3 again. Okay. We doing okay with that one? Okay. And then what were we saying with variables? So that's where the mixed number comes in. We can take out the whole amount. So if we look at 7 over 4, we can do, like we can take out a 4 over 4 or a 1. So we'd have x to the first power and then an additional 3/4. And then that just turns into x on the outside and then the 4th root of x cubed. Doing okay? Okay. And then what about y when it's just 1/4? Yeah, 4th root of y. Okay. What about z? What can I split that up into? It has 18 over 4 if you can't see it. Four on the outside. How many on the inside? 2, right? Because 16 goes evenly into 18. So pull out 4. We have 2 left. So what's going to be my outside part if I simplify it? Am I going to have a y? Yeah, there's no y. So we got 2x and then z to the 4th. And then what about on the inside? Yep. 18x to the 3rd y and then z squared. We doing okay? Do you want to try this one? Or do we want to go through it together? We can go through it together. Okay, what would be my first step? Okay, so we could do square root of 32 times square root of x to the 17th. Where would I go from here? Okay, so you want to do variable first? Okay, so I'll write that as a fraction. What's my denominator going to be? 2. Okay? So if I look at that, what's the power of x that I can pull out? 8. Because that 16 goes in there, and then 16 divided by 2 is 8. And then what would I have left? What's the power? Not quite. Because we'd have a 1 up there, right? And then it'd be 1 divided by 2. You get 1/2. Did I lose some people there?
Because that extra's going inside.
Yeah, that is.
Most people just didn't use the division stuff when we did it.
Okay.
Went over it with division, and most people just kind of ignored it.
Okay. But you understand what to do?
Yeah.
Okay. Because you were saying x probably on the inside. Yeah, there we go. Okay. What about 32? How can I simplify that? Square root of 32. Four on the outside, because we can split it up into 16 times 2. So we got 4 square root of 2, right? And then times x to the 8th. And then how could I write that 1/2 power as a radical? Yeah, square root of x. So what's going to be on the outside? 4x to the 8th. And what about the inside? 2x. We doing okay? Perfect. Okay, what about this one? Split it. So what would I have in the top? Yep. 50x to the 15th over square root of 3y. There's a certain rule that we have to think about here. No tenths in the basement, so we can't have a radical in the bottom. How would I get rid of it? Yeah, so if I multiply top and bottom by it, we're just going to get 3y in the bottom, right? What about the top? Multiply it in. So if we do 50 times 3, we get 150. We're not doing anything with the x's, and then we'll just have a y in there. Okay? What's my next step? Okay, simplify it. How could we simplify 150? Ten and 50, we can do that. 15, sorry. So we got 5, we got 2, we got 5, we got 3. So what was on the outside? 5. What's on the inside? 6. So 5, I'm going to leave a little space, and we'll do 6. Okay, what about my x's? 7x, x to the 7th will go on the outside, yep. And then what's on the inside? Just x. And do we do anything with the y? No, so just tax on there. How are we feeling? Perfect. Okay, what's the rule when we multiply variables with exponents? Yeah, we just add them. So, can I add these straight away? Yeah, technically no, we need a common denominator. So how would I change that negative 1/5? Negative 2/10. So what does that simplify down to? 5/10 or 1/2. So if I look at A or B, which one do we think? Can you see B okay? I'll scroll it up. Which one are we thinking? Do we know what makes an exponent go in the denominator? If it's negative, yeah. So is our exponent negative? So it's just A. With that 1/2. Okay, are we doing okay? Okay, we're almost done, I promise. This is like our last concept. So how would I go about this one? Distribute it out. If I distribute it out, what am I going to get? Okay. You want to do 6? Okay. Then we have minus 7 square root of x plus 42. Okay. What's my next step there? I can put those together. So I'd have x minus 13 square root of x plus 42. Doing okay? Are there any questions with this one? Nope. Okay. So what do we do when we solve a radical equation? Yeah, we gotta isolate it first. If you don't know the names, that's fine. You can just. So we gotta isolate it to one side. Okay. After that, what do we think we gotta do? If a radical's like over by itself, square it, cube it, whatever the power of the radical is. Okay. And then after that, we kind of just have to check to make sure all those radicals are gone. If they're not, we just repeat 1 and 2. Then we also have to check our solutions because some of them might not work. Kind of like with the rational expressions that we've been working on. Okay? Let's do this one together and then I'll have you do the next ones on the board, or the next one on the board. How would we solve it? Square it, okay? 21 squared, you got that? I think it's 441. You can check me if you want. I just remember doing it last period and I had someone do it. Okay, how do I solve for x there? Add 2, x equals 443. If I kind of think about it, will it give me 21? If I put 443 back in. Okay, doing okay with this one? I'll have you try that one.
Because we only use like the TI-84 and then
Oh, yeah. What'd you do first here? Square both sides. If I square both sides, what do I get on the left? 9t plus 3. What about the right? 4t plus 5. How do I solve for t? Subtract 4t, subtract 3. T is what? 2/5. Okay. I'll pull up Desmos just so we can kind of see it. I had it up earlier. If I can find it. There we go. There we go. So we got 4 times 2/5 plus 3. Then we have 9. Then we have 4 times 2/5 plus 5. Gives us the same value. Feeling good? Perfect. Got 2 more. Okay. What would I do for this one? Square both sides? Yep, I don't really have to think about isolating because it's already isolated for me. If I square both sides, what am I going to get on the left? X plus 27. Okay, what about the right? Yep. If I just wrote x squared plus 49, is that valid? Really? Can I do that? Yeah, because we have 2ab there. Okay, how would I solve for x? Yep. Would I want to move these two over here, or would I want to move all of this to this side? Yeah, we want to keep x squared positive. So I'm going to move those over, but I'm going to write this stuff first. So we got x squared plus what? Plus what? Yeah, 22. Equals 0. What are my factors then? (11 and 2, yeah. So we got x plus 11, x plus 2 equals 0. What are my solutions? X equals negative 11, negative 2. What do I have to do with those? Yep. So if I plug 11 into the radical of, or negative 11, if I do negative 11 plus 27, what is that? So then the square root of 16, 4. So I have 4 right there. And then if I do negative 11 plus 7, negative 4. So 11 does not work. So if I put negative 2 in there, we get square root of 25, which is 5. Then we have negative 2 plus 7, which is also 5. So negative 2 does work. Okay, last one. What would I do? Yeah, it's really intimidating. What was the first, sorry, what were you going to say? Yeah, there is a radical isolated. This one is. So this kind of goes in to that third part where if we do it once and still have radicals, then we kind of have to do it again. So if we did it once, if we square both sides, what do I get on the, we'll do the right first. What do I get on the right? X plus 20. What about on the left if I square this? That's, yep. So we got x plus 13 plus 2 x plus 13 plus 1, yep. Okay, are we okay with that? I broke it down last period, so if I need to break it down again, I can. Okay. Add everything together. What will I get if let's combine these ones first. Yep. And then haven't done anything over here. So we got 2x plus 13 on the inside. What's going to happen with those x's? Okay. And if I move the 14 over, what am I going to get? So then I get square root of x plus 13 equals 3. What do I got to do there? Square both sides. X plus 13 equals 9. Okay, what's my x value? Negative 4, yep. What do I have to do with that negative 4? Plug it back in. So if we do negative 4 plus 13, what does that give us? 9. So then the square root of 9 is 3 plus 1 is 4. So then if I do negative 4 plus 20, 16, square root of 16 is 4. So that negative 4 works. Any questions? Alrighty, you have 17 minutes.